Okay, in the previous class, we discussed the design of a reinforced concrete beam, simply supported, and we calculated the reinforcement, which came out to be 5 number 6 bars if we were using number 6 bar. So now how to place those bars in the beam, this is called drafting. This part is very important because finally the beam will be constructed in the field based on your drawing or drafting. Okay, can you see the slides?
Yes, sir.
So I told you that we can provide all the 5 bars in the same layer. For example, if we provide all the bars in the same layer, then we must confirm that whether the clear spacing between 2 bars that satisfy the ACI code criteria or not. Okay, so how to calculate the clear spacing between 2 bars? It's very easy because these bars are given within this distance, that is the inner space, the distance between two lengths of the strips. And how to calculate this distance? The total width of the beam is 12 inches. Now can you calculate this distance? G.
12 minus 1.5 minus 1.5 minus 3 by 8
12
minus
uh,
yes,
is
1.5.
the strip view is 3 by 8 inch.
9.75.
So this will be equal to 12 minus 1.5 clear cover on one side minus 1.5 clear cover on the other side minus 3 by 8 inch dia of one leg and minus 3 by 8 inch dia of the other leg. तो कितना आ रहा है?
8.25.
It is coming 8.25 inches. Now from this you can subtract the space occupied by the bars. So this will be equal to 8.25 minus how many bars are provided? 5. And what is the dia of a single bar? It is 3 by 4. So ये जरा आप calculate करें. Now this will provide you the total space available between the bars.
4.5.
किसके बराबर है? दोबारा बताइए जरा.
4.5. 4.5.
4.5 inches. Now, what will be the clear spacing between any 2 bars? So this is the total space available between these bars. Now 4.5 clear spacing between 2 bars between any two bars will be equal to this total available spacing divided by number of spaces. So 1, 2, 3, and 4 divided by 4. You calculate करें शाबाश.
1.125.
1.125 inches. Now, this spacing, though it is allowed by the code, if you remember, I told you in the last class that the clear spacing between two bars as per code shall be greater of 1 inches dia of bar which are dia of that longitudinal bar which is used in the beam, and 4/3 of maximum size of aggregate. Normally we are using 3/4 inch down aggregate, so 4/3 multiplied by, if we use 3/4 inch down aggregate, so it is giving us 1 inch clear spacing. Dia bar in this case is 3/4 and it is fixed, it is 1 inches. So the governing is 1 inch spacing because greater of these three is 1 inches. So though code allows this much spacing, clear spacing between the bars, but as I told you in the previous class that we recommend that the clear spacing between two bars will be at least 1.5 inches based on the local conditions at the field, at the site. Clear? So if we want to provide a clear spacing between two bars equal to 1.5 inches, then this spacing is not sufficient and we will provide these bars in two layers. Clear? So this is rule number 1 for drafting, that the clear spacing between two bars shall be as per code this one, but we recommend that it shall be at least 1.5 inches. तो बस आप याद रखिए इसको, clear spacing between two bars shall be 1.5 inches. Clear? Respond करें.
Yes, sir.
सर
Now, जी.
सर एक क्लियर में कितने बार हो सकते हैं, मैक्सिमम और मिनिमम?
तो तुम मैक्सिमम आप इससे निकाल सकते हैं ना, 1.5 इंच क्लियर स्पेसिंग आपके पास होनी चाहिए. बस इसमें जितने भी आप प्रोवाइड कर सकते हैं. मिनिमम की अलबत्ता ये है कि मिनिमम विल डिपेंड ऑन दी, you can calculate based on an equation which is provided basically to control the crack width in the beam. तो नॉर्मली अगर आपके पास 14 इंच बीम विड्थ हो तो उसमें 2 बार्स आप प्रोवाइड कर सकते हैं. अगर 14 इंच से ज़्यादा हो तो फिर आप कम से कम 3 बार्स प्रोवाइड करेंगे. क्लियर?
जी सर.
और मिक्सिंग तो आपके पास इससे आएगी, बस आप उसके दरमियान क्लियर स्पेसिंग ये क्राइटेरिया अगर फुलफिल करता है, जितने भी बार उसमें आ सकते हैं आप प्रोवाइड कर सकते हैं. अब इसमें आप देखें हम बिकॉज द क्लियर स्पेसिंग इज लेस देन 1.5 inches, so we will provide these bars in 2 layers. Now the second drafting rule is that if you are providing this in 2 layers, okay, 3 bars will be provided in the first layer and 2 bars will be provided in the second layer. So now, first of all, the question is that what will be the clear spacing between these two layers, first layer and second layer? What will be the clear distance between first layer and second layer? Again, as per code, this distance sorry, this clear distance between two layers shall be at least 1.1 inches, but we recommend that it shall also be equal to 1.5 inches, so that the concrete may flow around the bars and it makes a perfect bond with the steel. Clear? तो बस ये आप याद रखें, the clear distance between two bars in the same layer or the clear distance between the bars of different layers shall be at least 1.5 inches. अच्छा, अब आप ये बार्स को इस तरह भी प्रोवाइड कर सकते हैं. दिस वाज द सेकंड रूल. क्लियर? अच्छा, बार्स तो आप इस तरह भी प्रोवाइड कर सकते हैं. फॉर एग्जांपल, आप ये दो बार्स यहां पर दे दें. But now there is a third rule. This is not allowed as per the code, because code says that if we draw the centroidal axis, vertical axis of this section, so as per code, the bars provided in the beam shall be symmetric about this axis. Clear? So you can see that the bars provided in the second layer, they are not symmetric about the vertical axis. The bars provided at the left side, or the reinforcement provided at the left side, is more than the reinforcement provided at the right side of the section. Okay, this is not symmetric, so this is not allowed. So you have to provide the bar like this. Clear है?
Yes, sir.
अच्छा, अब आप ये दो बार्स तो इस तरह भी प्रोवाइड कर सकते हैं. अगर आप देखें ये सिमेट्रिक भी है अबाउट centroidal axis. अगर हम उसको देखें तो the bars provided on the left and right side, they are equal, they are symmetric. But there is another fourth rule of drafting, that this is also not allowed as per the code, because the rule says that each bar in the second layer shall be provided exactly over the bar of the first layer. So इसमें आप देखें, this is not lying over the bars of the first layer. So the only way to provide these two bars is like this. Now you can see that it is symmetric, as well as the bars of the second layer are lying exactly over the bars of the first layer. Any question? Clear नहीं?
Yes, sir.
Now, as a final step, you have to calculate the actual reinforcement. So that is very simple. 5 number 6 bars है तो आपके पास total reinforcement, the actual provided reinforcement is 5 multiplied by 0.44. It is equal to how much?
2.2.
2.2 inch square. And now, based on this, on the provided reinforcement, you will calculate the actual effective depth. Okay. So how to calculate the actual effective depth? Now I am not showing the stirrups for clarity. So you can calculate the actual effective depth. First of all, we will calculate the centroidal distance of first layer, which is denoted by y1, and centroidal distance of the second layer denoted by y2 from the extreme tension fiber. Now, the centroid of reinforcement, distance of the centroid of reinforcement is denoted by dc, and I told you that the actual effective depth will be equal to h minus dc. But how to calculate dc? Because the bars provided in the first layer and second layer, they are different, reinforcement is different, so you can calculate the centroidal distance from Varignan theorem. अच्छा, इतना तो आप बता सकते हैं, this centroidal distance, this centroidal point, it will be closer to layer 2 or layer 1?
Layer 1.
Layer 1, because reinforcement in layer 1 is greater than reinforcement provided in layer 2. Clear? अच्छा, ये किस तरह का कैलकुलेट करेंगे? ये बिल्कुल सिंपल है. The DC will be equal to A1 Y1 plus A2 Y2 divided by A1 plus A2. So A1 is equal to 3 multiplied by 0.44. How much is the area?
1.3.
1.32 inch square. And area provided in layer 2? Two multiplied by 0.44, 0.88. Yeah. Now, quickly calculate the distance of layer 1, centroidal distance of layer 1 from the face of the beam, extreme tension face of the beam. ये जरा बताएं शाबाश. It will be equal to 1.5 inch clear cover plus 3 by 8 inch dia of stirrup and plus half the dia of longitudinal reinforcement, which is equal to half 3 by 4. तो ये जरा बताएं मुझे. I have not shown the stirrups for clarity. Y1 बताएं शाबाश.
2.25.
This is equal to 2.25 inches. And from this you can also calculate y2. Y2 will be equal to y1 plus half dia of this bar and plus clear distance between these two bars, which is 1.5, and then half dia of this bar, which is again 3 by 4. तो ये जरा आप बताएं, y1 की वैल्यू इसमें डालें 2.25, तो y2 is equal to 4.5 inches. अब इसमें ये वैल्यूज डालें. A1 is 1.32 multiplied by y1 plus A2 is 0.88 multiplied by 4.5 divided by 2.2 total area. A1 plus A2 अगर हम करें ना so it will give you total area
3.15.
This is equal to 3.15 inches. These are confirmed करें Shravan?
Yes, sir. Correct.
Okay. Now the actual effective depth will be equal to 18 minus 3.15. तो ये जरा बताइए वैल्यू
14.85.
14.85 inches. This is the actual depth. Clear? Now, based on the actual provided area, you can also calculate the depth of compression block, actual depth of the compression block. It will be equal to AS Fy divided by 0.85 FC prime B. So AS is 2.2 multiplied by Fy is 60, 0.85 multiplied by 3 multiplied by 12. So what is the value?
4.31.
4.0
4.31.
31 inches. Now finally you will calculate the actual flexure capacity of this beam based on the provided reinforcement, based on the final drafting. So that is equal to phi Mn is equal to phi As Fy into D minus A by 2. Now you will put all these values based on the actual drafting. So phi is 0.9 multiplied by As is 2.2, Fy is 60, D we have just calculated, it is 14.85 minus A is 4.31 divided by 2. So can you calculate the actual flexure capacity?
1508.166.
1508.1 or 0.2 inch tips. If you remember the demand, what was the demand? MU.
1560.
It was equal to 1560 inch tip. If you remember, there was a beam, simply supported beam, on which dead load of 1.5 kip per foot was acting, and live load was equal to 1 kip per foot to the 0.5 kip per foot. So from this, the length of beam was 20 feet. If you calculate the moment, first of all you will multiply these with load factors, and then you will calculate the mixing moment. So it was finally equal to 1560 inch. I think you remember this. Now you can see that. Do you remember this?
Yes, sir.
If you see the capacity, the actual capacity is coming less than the demand, which is 1560 inch. What you will do?
D को increase कर.
तो D को तो increase नहीं कर सकते ना?
area of steel increase करते हैं, एक extra bar.
हाँ. We will provide an extra bar in the beam, So it will increase the reinforcement, and since अगर आप देखें फ्लेक्सर कैपेसिटी को, इक्वेशन को अगर आप देखें तो you can increase the flexure capacity by increasing the area or effective depth or by increasing the grade of steel. However, since normally the material properties are fixed, so you can increase the capacity by increasing the area or by increasing the depth of the beam. Clear? So in this case, we will just add another bar here, and this will basically satisfy the given demand requirement. Clear? अब इसको दोबारा कैलकुलेशन भी इसकी काफी सिंपल है, क्योंकि अब आपने इसी y1 y2 इसकी जरूरत नहीं है, because now the bars provided in both layers they are same, so the centroid will be exactly at the center of these two layers. Clear? तो दोबारा जरा चले कर देते हैं. The final design section, it will be like this: 3 bars in the first layer and 3 bars in the second layer. Now actual reinforcement you can calculate very easily. It is 6 multiplied by 0.44. How much is the area now? 2.64 inch square. And the depth of compression block based on this will be equal to ASFY divided by 0.85 FC prime B. So 2.64 multiplied by 60 divided by 0.85 multiplied by 3 multiplied by 12. वैल्यू बताएं.
5.17.
5.17. Okay, now you can very easily calculate the centroidal distance of reinforcement from extreme tension phase, which is noted by DC, and this DC will be equal to 1.5 inch clear cover plus 3 by 8 inch die of stirrup plus die of longitudinal bar in the first layer, the stirrups, the first layer, and plus half the distance, the clear distance between these two layers, which is equal to half of 1.5 inches. तो ये जरा वैल्यू बताएं. अच्छा, क्वालिटेटिवली आप बता सकते हैं ये डीसी प्रीवियस केस से ज्यादा होगा कि कम?
सर कम होगा सर.
डीसी ज्यादा होगा.
ज्यादा होगा.
3.37.
ज्यादा होगा, because in that case the reinforcement provided in layer 1 was greater than reinforcement provided in layer 2. So the centroidal point was closer to layer 1. So DC in that case was lesser. Now since the reinforcement provided in both layers is same, so it will be just at the center. Please will you बताएं DC?
3.375.
3.375.
375.
3.375. Clear? Now from this you can calculate the actual effective depth, and this will be equal to 18 minus 3.375. ये वैल्यू जरा बताएं.
14.625.
14.625 inches. So again, जी
सर ये reinforcing बार exactly स्टेज पर रखेंगे फर्स्ट लेयर वाली
बिल्कुल एग्जैक्टली स्टेप पर रखेंगे, बिल्कुल एग्जैक्टली स्टेप पर रखेंगे।
तो सर सेकंड लेयर के टेक्सचर नहीं होगा प्लीज इसको किस तरह रखेंगे
हाँ, सेकेंड लेयर को अगर आप देखें, ये जरा माइक ऑफ करें। सेकेंड लेयर में अगर आपके पास दो बार्स हो, जिस तरह प्रीवियस केस में हम डिस्कस कर रहे थे, इफ यू आर हैविंग ओनली दीज टू बार्स, ओके, so you can maintain this clear distance by binding these two bars with a bending wire with the stirrup legs. Clear? अगर दो बार दो, but if 3 bars or more than 2 bars are provided, then you have to provide a spacer between these bars. यहाँ पर हम एक स्पेसर देंगे which will maintain the clear distance between these two bars. We can give this spacer at, for example, at 18 inch or at 24 inch center to center distance. Clear? अब clear है?
yes sir clear
So about this spacer you will provide the second layer. अगर दो बार्स है तो फिर इसकी जरूरत नहीं है, because you can bind those bars with the stirrup legs. Clear? अच्छा, now calculate the actual flexure capacity, which is will be equal to 0.9 multiplied by AS 2.64 into 60 minus A by 2. ये कैलकुलेट करें स्वामी।
1716.4.
1716 inch skips, which is greater than the demand moment, which was equal to 1600 inch. Sorry, it was equal to 1560 inch. So this was the final step in the design of a reinforced concrete beam, singly reinforced concrete beam. Clear? Now, if you have any question, you can ask the question. Otherwise, we will start the design example given in the slides. यही चीजें हैं, बस ये ऑलरेडी हम डिस्कस कर चुके हैं. We will just quickly go through that example. Any question? Now, this is an example. Design the beam shown below as per ACI 318. You can see that the beam is supporting on walls. Practically, there will be no hinge supports, जो हम आमतौर realize करते हैं. But if the beam is simply resting on the walls, you can assume that the beam is a simply supported beam. Clear? And this assumption, this is a realistic assumption. It is based on the behavior of the beam. अगर आप देखें, आपके पास अगर we can idealize this beam by a simply supported beam like this, and this will closely basically depict the behavior of this beam, the actual beam. This is what is called idealization. And अगर आप for example इस support को हटाएं, what will happen? कोई बता सकता है? If we remove this support, so it will rotate like this. Okay, So the same case is here. If we remove this support here in the idealized beam, so it will rotate like this. So since this simply supported beam can basically represent the behavior of the true beam closely, so we can represent this by a simply supported beam. अब clear है? यानी simply supported beam जो hinges वगैरह होते हैं तो predictive नहीं होते. This is idealization. Okay. Now the total length, the center to center length, the between the supports, it is 20 feet. FC prime 3 KSI and FY is 40 KSI. That 40 steel हम use करेंगे. The dead load, अब आप यहाँ पर देखिए excluding self weight. मैंने आपको बताया था if there is excluding self weight term, so then after selecting the beam size, you will calculate the self weight of the beam and you will add that self weight with this dead load. बात समझ आ रही है?
Yes, sir.
And the live load provided on the beam, it is 0.5 kip per foot. First of all, the step number 1 is to select the sizes. So I told you that you can assume the width of beam as 12 inches, 15 or 18 inches. In this case, we will assume the width of beam as 12 inches and the depth of the beam can be calculated. The minimum depth can be picked from the ACI table. So according to ACI table, for 20 feet length, minimum length for simply supported beam will be equal to L by 16. And then since it is grade 40, so we will multiply this with a correction factor which is equal to 0.4 plus 40,000 divided by 100,000. For any other grade of steel other than grade 60, you will multiply this value with this correction factor, because if you remember I told you that the ASA table is basically developed for grade 60 steel and normal weight concrete. So you can see finally the minimum depth required for grade 40 steel, it is 12 inches. This is the minimum depth, and as I told you that you can exceed this depth. Okay, you cannot provide less than this, but you can provide greater depths than this value. Clear? So finally we will select 18-inch beam, 12 by 18-inch beam. Clear? Generally the minimum beam width is 12 inches, therefore width of beam is taken as 12 inches. So 12 by 18-inch beam is selected. The final selection of beam size depends on several factors, specifically the availability of formwork. तो ये जो हम select कर रहे हैं ना, directly हम 18 inch हमने select किया. It depends on many factors, but mainly it will depend on the formwork availability. What type of formworks are available? Because this beam will be part of a reinforced concrete structure, and in which there will be slab in the top and beams will be provided to support the slab. So normally, since we provide 6-inch thick slabs, if the width of the beam is 12 inches and the total depth is 18 inches, so 18 minus 6, so this clear depth or the drop of beam, this is 12 inches. So 12 by 12 inch formwork is easily available in the field. So that is why we selected 12 by 18 inch deep peak. बाकी basic reasons हैं. The beam provided shall be at least 3 times the thickness of the slab. So 18 inch deep beam is also satisfying that criteria. Clear?
सर ये जो 18 इंच का डेप्थ है बीम का, ये इंक्लूडिंग जो थिकनेस ऑफ द स्लैब है ये, या सिर्फ बीम का?
Yes, including the thickness of slab. ये हम फिर टी बीम वगैरह में पढ़ेंगे, यहाँ पर तो हम जस्ट रेक्टेंगुलर सेक्शंस को पढ़ते हैं. सही.
यस सर.
अच्छा, now the depth is 18 inches, so from this you can calculate the effective depth, which we can assume that it will be equal to 18 minus 2.5, so it is 15.5. अच्छा, ये assumed है. Finally, जब हम प्लेस करेंगे इसमें reinforcement, तो आप लोगों को पता है we will calculate the actual D, and based on the actual reinforcement and actual D, we will calculate the flexure capacity. ये भी हमने किया. सही. Width of beam cross section is 12 inches. In reinforced design, width of beam is usually denoted by BW instead of B, because this is width, the width of the beam width. क्योंकि मैंने जिस तरह कहा कि practically it will be part of the reinforced concrete system, so in that case this lower part of the beam, this is known as width, and that part of the beam which is lying within the slab, it is known as flange. अच्छा, B या BW जो भी हो आप इसे डिनोट कर सकते हैं. Now first of all you will calculate the self weight of the beam, which is equal to unit weight of the beam multiplied by cross sectional area of the beam. 0.15 multiplied by 12 by 18 to convert this into foot square divided by 144. So this is the self weight of the beam. Calculate the ultimate load. It will be equal to 1.2 into dead load. Now dead load is 0.5 plus self weight and plus 1.6 multiplied by live load. So finally the ultimate load acting on the beam is 1.67 kips per foot. Now you can draw the shear force and bending moment diagram like this, but since we are only designing for the moment, so you can calculate directly maximum moment demand from this. It is equal to WUL squared divided by 8. So finally the moment, vector moment is 1002 inch kips. Now you know the trial and error method. You can calculate, first of all you will assume A is equal to 0.2D, which is coming 3.1 inches. From this you will calculate A, it is coming 1.9. Recalculate the A value, it is coming 2.61. And after several trials, even at the third trial, you can see that it gives closer value to the value of the second trial. So finally the design reinforcement is 1.95 inch square. Now check for maximum and minimum reinforcement. Minimum reinforcement is greater of these two values, and I told you that this will mostly give you the greater value. So it is coming 0.744 inch square. For grade 40, you already know that the minimum reinforcement will be 0.5% of BD. This is not governing, this is governing. The second equation. 0.93 inch square is the minimum reinforcement. Maximum reinforcement it is 0.3 FC prime by FY BWD. या already अगर आप लोगों को याद हो 2.25% of BD or grade 40 and with 3000 psi concrete. It is coming 4.2 inch square. Now the calculated area, it is less than the maximum and greater than the minimum, so it is okay. Now as I told you, you can provide different size of bars, 4 number 7 bar, 3 number 8 bar, or combination of 2 different size of bars. But as I told you that the difference between 2 bars shall be difference between the bar shall be 2 bar sizes. Now 5 number 6 bar will provide 2.2 inch square area. आप लोगों को पता है this is slightly greater than required, but we can provide 5 number 6 bar for the given beam. That's on Mary. The required area is 1.95 inch square. Clear? So आप यानी reinforcement थोड़ा ज़्यादा दे सकते हैं, सही? You can see that this is the final drafting. 3 bars are provided in the first layer, 2 bars in the second layer. इस तरह हमने किया था. And 2 number 6 bars, they are provided in the top just to hold these stirrups. Now these bars, you can provide these bars 2 number 4 bars. Because these are not coming from the design. This is not the demand requirement. These are provided just to hold these stirrups. That's how Mary.
Yes.
अच्छा, अब आप इसकी एक्चुअल फ्लक्स कैपेसिटी कैलकुलेट कर सकते हैं. अभी हमने कैलकुलेट किया था. What was the value? .2 inch skips. ये भी हमने कैलकुलेट किया था ना. बिल्कुल वही केस है. 3 bars in the first layer, 2 bars in the second layer. So the capacity is equal to 1508.2 inch skips. और डिमांड अगर आप देखें, डिमांड is given here. It is 1002 inch skip. So the capacity is greater than demand. The provided reinforcement is sufficient. Clear? बाकी कैलकुलेशन वगैरह ये ऑलरेडी हमने की है. आप जरा इसको देखें. y किस तरह कैलकुलेट करेंगे? 3.15 ऑलरेडी हम ये कर चुके हैं. क्लियर है ना?
सर वो तो ग्रेड 60 के लिए थे, 60 के साई के लिए.
अच्छा, मगर ये कैलकुलेशन तो खैर वैलिड है ना.
यस सर.
डी तो सेम रहेगी. देयर विल बी डिफरेंस इन द ए एंड द फाइनल कैपेसिटी. अच्छा, तो यहाँ पर आप जरा देखें. ए विल बी स्लाइटली lesser because Fy is now grade 40. In our case, it was I think 3.1 inches or something like that. No, it was 4 inches. It is in this case it is 2.87 inches. And if we calculate the phi mn, so now you can see it is slightly greater than the demand, but since it is greater than the demand moment, so the design is sufficient. Okay. In case of grade 60, what was the value? 1508.2 inch skips. Same beam, but you can see that In case of grade 60, it is giving you 1500 inch capacity. And in case of grade 40, it is almost 1000 inch capacity. Clear? So you can also note the difference between the grade 60 and grade 40 steel. Up clear है? Our calculation was based on grade 60. Huh? The point clear है कि नहीं?
Yes, sir.
Now you can see this is the final drafting. अच्छा, यहाँ पर एक दूसरी बात हम डिस्कस करते हैं. If you see the moment diagram, we have designed the beam for this moment. And you can see that as we move toward the support, this moment is decreasing. And at the support, there is zero moment, which means that no bar will be required at the support. Now, if you move away from the center, you can reduce the amount of reinforcement. Is that right? Because if, for example, at this point, if you calculate the moment value, it will be somewhat 500 HK. Roughly, आप बता सकते हैं कितनी reinforcement required होगी? Roughly, just
3 divided by.
अगर यहाँ पर आपके पास 1000 इंच के लिए 5 बार्स रिक्वायर्ड है, तो 500 के लिए कितना होगा?
3 सर.
तकरीबन 3 बार्स. ओके, तो इसका मतलब ये that you can reduce the amount of reinforcement at the ends of the beam. तो इसको हम कहते हैं curtailment. और इसकी बस एक रूल आप याद रखें. If I draw the longitudinal section of this beam, ये तो आपके पास this is the cross section of the beam. अगर हम इसकी एक longitudinal view भी ड्रा करें, this is the simply supported beam. Now the bar provided in the first layer. This is the bar provided in the first layer, and the bar provided in the second layer will look like this. Clear about? Now what you can do, you can curtail the reinforcement provided in the second layer because it will not be required from the analysis. तो आप क्या कर सकते हैं, you can provide this second layer only in the central portion of the beam, and you can curtail that at distance L by 8 from the face of the support. ये बात याद रखें. This is, for example, support, wall support. So you can curtail these two reinforcement at a distance L by 8 from the face of the support. इसकी जो एक्चुअल डिटेल्स है वो आप देख सकते हैं नेल्सन बुक में कि कर्टेलमेंट हम किस तरह कर सकते हैं, मगर सिंपली बस आप इतना याद रखें without going into those details that you can curtail the pass-through reinforcement up to 50%, and you can curtail that at L by 8. Clear? Any question? ये clear है? तो
Yes, sir.
This section basically, ये जो हमने section ड्रा किया है, it is basically this one, section AA. If you draw a section A closer to the support, section BB, then in that section these two bars will not be there. Up clear है?
Yes, sir.
सर फर्स्ट लेयर कम कट नहीं करती सर?
नहीं, फर्स्ट लेयर का कार्ड नहीं। मैंने आपको जिस तरह बताया कि आप 50% से ज्यादा कर्टेलमेंट नहीं कर सकते, और फर्स्ट लेयर को तो आप नहीं कटेंगे। फर्स्ट लेयर में भी आप कर्टेलमेंट कर सकते हैं, यानी अगर आपके पास 4 बार्स हैं, if instead of 5 bars, if you provided 4 bars in the first layer only, तो उस केस में फिर आप you can curtail 2 bars in the first layer at L/8, तो वो आप इस तरह रिप्रेजेंट कर सकते हैं। बात समझ में आ रही कि नहीं? अगर आपके पास if you provide 4 bars instead of 5 bars in the first layer, okay, in that case you can curtail these 2 bars at L/8 because this will be 50% curtailment, okay, and you can represent that curtailment by these small hooks. Clear? इस केस में अगर आप फिर सेक्शन BB, this is section AA, and if you draw section BB, so in section B there will be only 2 bars in the B. Now is this clear to you?
Excuse me, sir.
जी,
सर इससे हमारे पास एरिया ऑफ रिइंफोर्समेंट कम नहीं होगा?
reinforcement कम होगा, but that reinforcement is not required at the support. क्योंकि आप देखिए यहाँ पर, यही तो मैं एक्सप्लेन कर रहा हूँ। This reinforcement which you have calculated is for the maximum moment which is there at the center of the beam. If you move away from the center at the ends, you will need less reinforcement than that, because as you move away from the center toward the support, the moment demand will be decreased. बस समझ आ रही है?
यस
तो ये curtailment हम सेंटर में नहीं करेंगे, it will be at the ends, और एंड पर आप देख सकते हैं the demand is small. Clear? So this is how you can curtail the reinforcement in the beam. अच्छा, सिंपली सपोर्टेड बीम में आप आगे पढ़ेंगे, ये तो जस्ट आपकी अंडरस्टैंडिंग के लिए, मगर इसमें नॉर्मली हम कर्टेलमेंट नहीं करते सिंपली सपोर्टेड बीम में। कंटिन्यू सपोर्टेड बीम में फिर हम कर्टेलमेंट कर सकते हैं। Now in this case, as I told you, normally spacer bar will not be required, but you can see that spacer bar is provided here. You can see the 3D view of the beam. These are the spacer bars which are provided to support the bars of the second layer. And you can see the closer stirrups at the end and stirrups provided at the wider spacing at the center. ये फिर हम डिस्कस करेंगे शेयर डिजाइन में, मगर इतना तो आप लोगों को पता है that shear force, if you see the shear force diagram of this beam, so it will be like this. shear demand is greater at the support and it is smaller at the center. So that is why the stirrups are provided at closer spacing at the ends and wider spacing at the center. This is animation of that beam. You can see the 3 bars provided in the first layer as continuous reinforcement, and 2 bars provided in the second layer have been curtailed at L by 8. This is a class activity. आप ये जरा start करें शाबाश. Design a reinforced concrete simply supported beam having a span length of 30 feet. So L is 30 feet and supporting a service dead load of 1.1 kg per foot and uniform service live load of 1.1 kg per foot. In addition to its self weight. तो इसमें भी आपने सेल्फ वेट को इंक्लूड करना है. सही. ये हम एग्जाम में ये इस तरह की टर्मिनोलॉजी नहीं होगी, या एक्सक्लूडिंग होगी या इंक्लूडिंग, ताकि आप लोगों में कंफ्यूज ना हो. क्लियर. एक्सक्लूडिंग हो तो बस फिर आप उसमें सेल्फ वेट ऐड करेंगे, इंक्लूडिंग हो तो उसमें सेल्फ वेट ऐड करने की जरूरत नहीं. If C prime is 4 KSI and Fy 60 KSI. तो अब आप जरा स्टार्ट करें. First of all, you will select the beam size. Okay. Beam size तो simple है. You can assume the beam width is 12 inches, and since it is grade 60 steel, so directly 30 divided by 16 multiplied by 12, it will give you the minimum depth. ये कितना आता है? कैलकुलेट करें शाबाश.
22.5.
22.
Yes, sir. 22.5.
अच्छा 22.5, मगर आप इसको 24 इंच ले सकते हैं. क्लियर. But I will recommend that instead of 24 inch, take 27 inches. तो beam size ये स्टेप मैंने आप लोगों के लिए किया. It is 12 inches by 27 inches. अब आगे आप खुद करें. चले सेल्फ वेट आप इसमें अगर इंक्लूड करें, चले डेड लोड में आप सेल्फ वेट भी इंक्लूड
सर
जी जी।
सर ये असाइनमेंट हो जाएगा ना, असाइनमेंट करेंगे हम।
ये तो एक्टिविटी है, असाइनमेंट कैसे होगा? दिस क्लास एक्टिविटी। चाहिए
ठीक है सर।
ये आप लोगों की प्रैक्टिस हो जाएगी ना। ये खुद आप सॉल्व करें, हर एक स्टूडेंट इंडिपेंडेंटली। रिइंफोर्समेंट जब कैलकुलेट करें तो मुझे वैल्यू जरा बताएं, ताकि मैं आपको बताऊं, कंफर्म करूं।
एक्सक्यूज मी सर,
जी
देखिए तो हमारे पास सर्विस लोड है, तो हम लोड फैक्टर से मल्टीप्लाई नहीं करेंगे, लेकिन जो हमारे पास सेल्फ वेट आएगा उसके साथ मल्टीप्लाई करेंगे।
आपकी आवाज़ तो सही नहीं आ रही, मगर आप इस तरह करेंगे कि आपके पास डेड लोड है 1.1 किप पर फुट, और इसके साथ आप सेल्फ वेट प्लस करेंगे, यानी आपके पास सेल्फ वेट विल बी 12 मल्टीप्लाइड बाई
सेल्फ वेट के
27।
साथ मल्टीप्लाई करेंगे लोड,
जी
सेल्फ वेट के साथ हम लोड फैक्टर मल्टीप्लाई करेंगे 1.2।
बिल्कुल, उसके साथ करेंगे ना। फैक्टर लोड किस तरह कैलकुलेट करेंगे?
बाकी तो ये सर्विस लोड है, इसके साथ तो फैक्टर से मल्टीप्लाई नहीं करेंगे, सिर्फ इसके साथ मल्टीप्लाई करेंगे सेल्फ वेट के साथ।
नहीं, सर्विस लोड का मतलब ये है कि आप इसके साथ मल्टीप्लाई करेंगे। सर्विस लोड का मतलब ये कि इसमें फैक्टर मल्टीप्लाइड नहीं है, तो आप तो फाइनली फैक्टर लोड के लिए डिजाइन करेंगे ना। इन डिजाइन में मैंने आपको बताया था, द लोड्स आर एम्प्लीफाइड एंड द कैपेसिटीज आर रिड्यूस्ड। ये तो हम बार बार डिस्कस कर चुके हैं। बात समझ आ रही है?
यस
यानी यहाँ पर गिवन है एक्सप्लिसिटली दैट सर्विस लोड्स आर गिवन, सर्विस लाइव लोड, सर्विस डेड लोड। इसका मतलब ये कि फैक्टर अप्लाइड नहीं है, तो फाइनली आप इसके साथ फैक्टर अप्लाई करेंगे, फैक्टर मल्टीप्लाई करेंगे टू कैलकुलेट द फैक्टर लोड। total factor load will be equal to 3.485. अपना आंसर जरा उसके साथ चेक करें.
यस सर, ये हमारे साथ दिया है 3.485.
हाँ बिल्कुल ठीक.
Sir,
जी जी,
area of steel 9.8 inch square.
ये आपने गलती की होगी।
5।
Sir, A को 0.4D लिया और 3.1 इंच लिया गया।
आपके पास आपने डी कितना लिया है?
सर D 15.5 एरियम।
सर
15.5?
सर सर
सर B 24.5 आते हैं।
सर
जी जी,
सर एएस मेरे पास 4.03 इंच स्क्वायर।
हाँ ये बिल्कुल ठीक है। 4 पॉइंट
03।
ये आपने सही कर।
अब इसके बाद मैक्सिमम और मिनिमम फाइंड कर रहा हूँ।
हाँ, मिनिमम और मैक्सिमम उसके साथ आप ज़रा कंपेयर करें।
ओके सर।
सर AS 4.96 गलत है ये।
It is coming 4.04 something like that. आपकी वैल्यू क्लोजर है मगर ये भी ठीक नहीं है। AS will be equal to 4.04 inch square. आप लोग अपना जरा कंपेयर करें इसके साथ। ठीक है, डी आपके पास होगा 224.5 इंचेस। एफ सी प्राइम आपने गलत तो नहीं किया है। एफ सी प्राइम आप जरा देखें। एफ सी प्राइम इन दिस केस इज 4 के साइज।
यस सर 4 है।
हाँ 4 और एफ वाई 60 है। इससे आप मोमेंट डिमांड कैलकुलेट कर सकते हैं 3.485। मोमेंट इज 4704। इस तरह आप लोगों के साथ
सर मेरे पास तो 4522 आ रहा है।
सर आपका
तो आप
सेम।
जी
सर यही आ रहा है हमारे।
हाँ 4704। 4704.74 इंच। और इससे आपके पास एरिया आएगी 4.04 इंच स्क्वायर। फाइल आप करें ना, मगर याद रखें कि इसमें एफ वाई 60 है एंड एफ सी प्राइम इज 4। इसको मैक्सिमम और मिनिमम इन्फोर्समेंट के साथ कंपेयर करें। Yes, max is equal to 0.27 fc prime divided by fy into bd, and as minimum 200 divided by fy into bd. इससे आपके पास वैल्यू आएगी 5.29 and minimum value is 0.98 inch square आएगा। इस तरह है।
Yes, sir.
So now since the calculated reinforcement is less than maximum and less than minimum reinforcement, so this reinforcement is okay. अब इसके बाद आपने क्या करना है? Calculate the number of bars if we are using number 8 bar for example. ये maximum minimum reinforcement के साथ आप सबने कंपेयर किया?
यस सर। सर ये इफेक्टिव डेप्थ 21.5 नहीं होगा 24 माइनस 2.5?
सर
24 तो नहीं है ना, हमने तो डेप्थ 27 सेलेक्ट किया है। आप क्या देख नहीं रहे? इस 27 बात समझ में आ रही कि नहीं?
यस सर।
जी इसके बाद आप नंबर ऑफ बार्स कैलकुलेट करें। If we are using number 8 bar for example, so 4.04 divided by 0.79, how many number of bars will be required?
6 सर।
सर सर ये तो 5.11 आ रहा है 1 2 तो हम क्या लेंगे 6?
हाँ 6 लेंगे ना, ज्यादा लेना चाहिए। सही
सर इसमें ऑलवेज राउंड अप होगा।
हाँ राउंड अप होगा। एक बार तो आप जरूर ज्यादा डालें क्योंकि फाइनली आप देखेंगे कि जो D है, if we are providing this in 2 layers, so D will be reduced substantially. So that will basically reduce the flux jet capacity. तो फाइनली अगर हम देखें तो this is that section. 3 bars are provided in the first layer and 3 bars are provided in the second layer. Okay. The width of beam is 12 inches. The total depth is 27 inches. And now you can calculate the actual D. The actual provided area is equal to how much? 6 multiplied by 0.79. जरा वैल्यू बताएं।
4.7.
4.78. 78 आ रही है।
4.74.
4.74. And what about this distance DC? So DC will be equal to
4.74.
1.5 plus 3 by 8 is straight dia plus 1 inch dia of this bar and plus 1.5 which is clear distance between the two layers divided by 2. Is there a value बताएं?
3.625.
3.35.
3.625.
3.625. Now from this, calculate the actual D, which will be equal to 27 minus 3.625. कितना आ रहा है?
23.375.
23.375. अब आप देखें, it has been substantially reduced. If you see, we assume the effective depth equal to 27 minus 2.5, which was 24.5. So that is why we are rounding up the design reinforcement. Clear? Because D will basically reduce the plug capacity. So depth of compression block भी आप calculate कर सकते हैं. It is equal to 4.74 multiplied by 60 divided by 0.85 multiplied by 4 multiplied by 12. ये वैल्यू बताया जरा.
$6.97.
6.9 inches. From this, you can calculate the actual flexure capacity, which is equal to 0.9 multiplied by 4.74 multiplied by 60 into D, which is 23.375 minus A by 2, which is 6.9 divided by 2. वैल्यू बताइए शाबाश.
5091.
509.
5091.
560.
5091.
5091 inch cape, which is greater than the demand moment, which was equal to 4704 inch cape. Clear? So the given beam with given reinforcement, it is okay. Clear? So this is how you can design the reinforced and assembly reinforced concrete beam. अच्छा, ये आप लोग जरा अपने साथ.
सर ये स्टार्ट में हमारे पास जो एक्चुअल डेप्थ आ रहा था वो तो कम आ रहा था सर. आपने कहा 27 ले 22.5 आ रहा था. ये क्यों हमने इतना ज्यादा लिया सर? शायद उसके लिए फिर हमारे पास कम आ रहा हो. ये कैलकुलेशन फिर डिफरेंट भी हो सकती है.
नहीं, अभी मैं तो एक्सपीरियंस के बेस पर ये कर रहा हूँ. खैर आप खुद कर सकते हैं अगर आप 24 इंच ले लें.
सर मेरा कहने का मतलब ये कि हमने कितना इंक्रीज करना है, मैं ये कह रहा हूँ.
तो यही तो मैं भी कह रहा हूँ ना. ये इट डिपेंड्स ऑन वेरियस फैक्टर्स. मैंने जिस तरह आपको बताया कि इट विल मेनली डिपेंड ऑन द अवेलेबिलिटी ऑफ फॉर्मवर्क. बीम के लिए जो आप फॉर्मवर्क है वो रेडिली अवेलेबल है कि नहीं. इसके अलावा आपके पास इसकी सर्विसिबिलिटी रिक्वायरमेंट्स है वो फुलफिल होते हैं कि नहीं. इसके अलावा अगर इस केस में आप देखें तो मुझे तो इन एडवांस पता है. इफ वी select a depth less than 27 inches, then the reinforcement coming in the beam will be greater than the maximum reinforcement allowed in the beam. आप खैर इसी प्रॉब्लम को खुद आप प्रैक्टिस करें. चलिए आपकी प्रैक्टिस भी हो जाएगी. आप 24 इंच डेप्थ ले लें और उसके लिए reinforcement. जी
हाँ सर, तो मैं ये कह रहा था अगर हमारे पास इस तरह का केस हो और हम किसी जगह पे डेप्थ बढ़ा नहीं सकते, फॉर एग्जांपल 24 से हम इंक्रीज नहीं कर सकते, तो फिर हमारे पास और क्या ऑप्शन हो सकती है सर?
हाँ बिल्कुल, ये हम कमिंग लेक्चर में इसी पे हम डिस्कशन करेंगे. सही.
ओके सर, ठीक है सर, थैंक यू.
सही, मगर चले आप एक प्रैक्टिस तो इस पर करें ना. इट इज काइंड ऑफ होम एक्टिविटी. क्या आप 24
Okay,
इंच डेप्थ ले लें, 24 इंच डेप्थ ले लें, इसके लिए इन्फोर्समेंट कैलकुलेट करें और मैक्सिमम इन्फोर्समेंट के साथ उसको कंपेयर करें। सही?
ओके सर, ठीक है सर, थैंक यू सर।
अच्छा, अब बिफोर कमिंग टू दी नेक्स्ट क्लास आप ये चीज़ें ज़रा करें अपने साथ। Calculate the maximum flexure capacity of these sections. ये अपने साथ ज़रा नोट करें। अच्छा, if C prime is 3 KSI and Fy 40 के लिए भी करें, Fy 60 KSI के लिए भी करें। Clear? Which means that you will have 8 answers basically. Clear? हर एक
Yes,
सेक्शन
sir.
के लिए 2 आंसर आएंगे ना, corresponding to grade 40 and corresponding to grade 60. जी, क्या क्वेश्चन है?
सर लोड्स वही लेंगे जो एग्जांपल में है, एक्टिविटी वाले में।
This is how to calculate the maximum flexure capacity of the section. So it doesn't depend on the load. The capacity will not depend on the load. बात समझ आई कि नहीं? देखिए आपके पास कैपेसिटी किसके बराबर है? phi mn is equal to phi as fy d minus a by 2. इसमें लोड का कोई है? It will depend on reinforcement provided, material properties and depth of the beam. बात समझ में आ रही कि नहीं?
सर
तो
एएस
कुछ
कहाँ से आएगा अगर लोड नहीं है?
तो मैंने आपको क्या कहा? कैलकुलेट मैक्सिमम फ्लक्चर कैपेसिटी। अब मुझे बताएं, एस कैलकुलेट कर सकते हैं कि नहीं? यार बिल्कुल सिंपल है ना, इसके मैक्सिमम रिइंफोर्समेंट कैलकुलेट करें इस सेक्शन की और उसकी करस्पॉन्डिंग आप कैपेसिटी कैलकुलेट करें।
यस सर।
सही? तो इन सेक्शंस की जरा आप मैक्सिमम फ्लेक्चर कैपेसिटी करस्पॉन्डिंग टू ग्रेड 40 एंड 60 ये आप कैलकुलेट करें, फिर हम कमिंग क्लास में इसको मजीद डिस्कस करेंगे। सही?
सर कमिंग क्लास तो ईद के बाद होगा।